Okay, so there is a problem in chromatography, okay, that we have to deal with. It is called general elution problem. Okay, so general elution problem, we have two types, fronting and also tailing. Okay, so remember, when we have our peak, your peak should be, your peak, okay, it should be well shaped. Okay, well shape macam mana? Dia macam sepatutnya keadaan ni. Ni yang warna merah. Okay, so it should be well shaped like that. Okay, sorry, kita tak boleh nak draw. Wait. Okay, so it should be well shaped like that. Okay. However, there are situations or conditions in which dia boleh berlaku fronting and also tailing. Okay, so what is fronting and tailing? So fronting, it often occurs as the result of overloading the column with a sample. Means that we put a lot of samples, so tak mampu the column to interact with, so there will be overloading and there will cause fronting. So this is fronting. So the green chromatogram is the asymmetric peak. Sepatutnya kita dapat symmetric peak macam ni. Maksudnya kanan kiri ni sama. Bila kita bagi dua, kanan kiri sama. But now when we split into two, of course this one lebih. Okay, so the red dash chromatogram shows the ideal Gaussian peak shape. So your peak sepatutnya kalau dia ideal, dia patutnya Gaussian peak shape. Macam ni lah, bentuk macam ni, ataupun yang merah ni. But now something happen in which there will be overloading of column with a sample. We put a lot of sample, then fronting happen. So fronting is here. Kat depan lagi banyak. The inlet shows that the relationship between the concentration of solute in the stationary phase and its concentration in the mobile phase. Okay. So supposedly dia macam ni, dia punya relationship. Bila dia dah ni, dia akan it is directly proportional, and then dia reach equilibrium lah. Okay, relationship kita punya analyte dengan mobile phase dengan stationary phase kena naik macam tu, and then dia akan keluarlah eluted sebab mobile phase yang carry the analyte. But as you can see here, instead of going like this, makin lama makin tinggi ada mobile phase, so mobile phase yang carry dia tu, tapi dia tak nak, so it go or it deviates to the stationary phase. So dia ke arah stationary phase lagi. Why? Because it is overloading. Sample tu overload. So dia nak stay longer inside the stationary phase. So nak tarik tu susah. So that is why there will be fronting here. Okay, fronting. Okay, so fronting, of course, it is at the front of the peak. So jangan confuse ya. Remember, this is not front. Ini fronting depan ni lah. Kita tengok dia punya time. Okay, yang keluar dulu. So fronting is at the front of the peak, and tailing is at the back of the peak. Dekat belakang ni. As you can see, sama juga. Sepatutnya ikut Gaussian peak, dia mesti macam ni. Yang merah ni. But now it is more. Then that it becomes asymmetric, dah tak sama. So tailing, why tailing occur? It often occurs when some sites on the stationary phase retain the solute more strongly than the other sites. Okay, so this may occur or happen due to, contohnya macam we have polar analytes, and then kita ada dekat sites kita stationary phase tu kita ada OH punya group. So dia akan lekat longer dekat sini, absorbed longer. So the green chromatogram is the asymmetric peak, and the red dash is the ideal peak, which is based on Gaussian peak shape. So the inlet shows, here look at here, shows the relationship between the concentration of solute in the stationary phase and its concentration in the mobile phase, and the quantitative measure of the peak. Okay, so fronting happen when the tailing factor is less than 1. Gaussian tailing factor equals to 1. Maksudnya sama. Okay. Nanti measure of peak tailing. So kita boleh measure lah peak tailing ni T. T equals to B over A. Ni. So A the half parts ataupun half width dekat sebelah depan, B dekat sebelah belakang. Okay, so fronting happens when the tailing factor is is lesser than 1. So fronting will happen. Kenapa? Bila dia lesser than 1, sebab bawah tu bila A ni lagi besar. So when A is bigger than B, what happen? So your T will be lesser than 1. Sebab bawah lagi besar, right? So it is fronting. But when A equals to B, A ni sama dengan B dekat sini. So tailing factor is equals to 1. So we have a Gaussian peak shape, which is the ideal shape. This is the ideal shape. Dia mesti sama. But when the tailing factor is equals to 1, is more than 1. Bila more than 1 ni, when A is lesser than B, or when B is more than A. So your tailing factor will be more than 1. So tailing occur. Okay. So you can find or calculate this by using the formula there, tailing factor. Okay. And why do bands spread? Okay, so we have this. This is called why do bands spread? So supposedly this is the shape that we want to get, Gaussian peak shape. But sometimes we may get this kind of peaks, or we may get this kind of peaks. So all these peaks are called broad bands. Broad bands. So why do these bands spread? Okay, there are a few factors. It may be caused by eddy diffusion, A factor. It may be caused by mobile phase mass transfer or stationary phase mass transfer. Ni sistem lah, CSM, stationary mobile phase. Ataupun iaitu stationary phase lah, CSV. Ni CSM. Okay, and it may also caused by longitudinal diffusion, B term. So band broadening, it happens caused by these three terms lah, A, B and also C. Nanti saya terangkan kenapa. Okay, so look at the first one, eddy diffusion. What is eddy diffusion? It is a process that leads to peak band broadening due to the presence of multiple flow paths through a packed column. Okay, so this happen when we have packed column. Okay, so in chromatography kita ada dua. We have packed and also capillary. Okay, saya tengok balik ya. Okay, so this yang kita dah belajar hari tu. So in this one, kita ada A term, eddy diffusion or multipath. Kita ada kat sini untuk open tubular, there is no A, tak ada A term. Kenapa tak ada A? Sebab tak ada particles kat dalam tu. There is no particles there. Okay. So what happen when we have those particles here? Bila kita ada kat sini, when your analytes ataupun punya mobile phase lalu, there will be a lot of ways. Dia ada banyak jalan. Dia boleh lalu dekat ikut sini. So dia ada banyak jalan. So that is why nama dia multiple path ataupun banyak dia punya jalan lah. Tapi when we use open tubular capillary, dia lalu kan satu line sahaja. Okay, so in multiple flow paths or eddy diffusion, what happens since we have particles here inside this? When you have your analyte have molecules. So molecules is made up from banyak lah kan? So the molecules will travel through the column differently. So some will arrive sooner, then ada yang akan arrive later. So when this happen, there will be band broadening. Cuba tengok kat sini. Now, this is the solid molecules of the same analytes lah, analyte yang sama. Okay, so peak yang sama lah. So, dia ada banyak molecules. So, dia akan jalan. The first molecule, dia lalu ikut sini. But the second molecules, dia lalu ikut sini. It takes different path that is longer. So, we know that number 2 will reach or will what we call that, reach the detector later as compared to 1. And if we have another one, number 3, for example, the third molecules, dia lalu lain pula jalan, dia lalu jalan ni. Okay. So, it will take longer time as compared to the first path and the second path. Okay, so as you can see that longer path arrives at the end of the column after. Okay, so this is what happen as eddy diffusion. Bila banyak path, dia akan lead to band broadening. So bila ada path, term ni, eddy diffusion ni banyak jalan ni, so dia akan keluar berlainan lah. Okay, so look at this. Okay, so the first solute, it travels through the shortest speed. So dia sampai paling awal. The second solute, dia ambil jalan yang lagi jauh. So dia reach here. But the third solute, dia ambil jalan lagi jauh. So as you can see here, it have broad. Besar. Kalau contohnya number 2 ni ambil jalan, number 3 ni ambil jalan jauh, number 3 ni jalan lagi jauh. Okay, macam tu. So, lagi broader peak. And this may occur, kenapa? Because we have particles here. When we have particles here, and then kita akan ada different path. Tapi kalau kita ada particles kat sini, macam open tubular column kan, dia duduk kat tepi je, dia punya particles ni, ataupun it coated directly onto the wall. So, jalan dia satu je. So, dia tak adalah multiple path. So, nak tak nak all the solutes mesti lalu jalan yang sama. So, it will reach at the detector at the same time. So, tak ada eddy diffusion. But if you use packed column, there will be these obstacles and then dia akan ikut jalan yang lain. You can imagine this as analogy. Awak nak pergi kelas, right? So, ada orang lalu jalan yang shortcut. Ada orang lalu jalan yang jauh sikit. Jadi tak kena panas. So, there will be a lot of paths. So, bila path tu berlainan, walaupun awak keluar pada waktu yang sama, you will reach the classroom at different time. So, macam itulah. So, when you have obstacles here, so you have eddy diffusion. And this one only happen in packed column.